And we are live again. Hey Nish, hey Michael, how are you both?
I'm well, thank you, very well.
Thank you very much for joining us again, Michael. It's really appreciated.
Oh, not a problem, sir, not a problem.
You're a gentleman. Could I ask you to be kind enough to share your screen so we can flick between them whenever you want?
Oh, so, yeah, just one.
What did you get up to in the last 10 minutes since I last spoke to you, Nish?
Getting all the links out. So everyone can see them.
Yeah. So many places to post and share, and sometimes I always feel like I'm just kind of like, yeah. I remember the days of the megaphone. Just get one megaphone, share everything through that. It was all good. Brilliant. Right, Michael. Whenever you're ready, buddy. Just please introduce yourself again, well, guys. We're very lucky to have Michael Scott with us, a really experienced teacher and tutor. Thank you. That's the postman, the only person I get to see, isn't in my family. Just dropped off some mail. But Michael Scott, a very experienced teacher and tutor as well. And obviously, Michael, do you feel that teaching online is any different to how you would teach normally in a tuition rather than in class?
I actually find this more effective because you can get that instant feedback. Especially when you pose problems and questions on these whiteboards, and you can learn from the student, and the student can also learn from you. So they're not, I tend to find students aren't as afraid to make mistakes, and they're more open to showing they're working out and showing actually what they're thinking.
What, without the pressure of the teacher being right there in front of them?
Exactly. Yes.
Crazy. All right, brilliant. Well, thanks a lot for that insight, because there's a lot of teachers watching. A lot of teachers I'm asking to help and volunteer as well, but I don't want to take any more of your time. Thank you so much again, Mike. Your screen is now being presented, and we're off and away with atoms.
Not a problem. So the lesson for today, we're going to look at the building block for a lot of substances on Earth. Everything in the chemical world is built up from atoms. And we're going to start off really with like chemistry 101, and that is just looking at the structure of the atom. So you'll see over here that I've drawn a nuclear model of the atom. The reason we call it the nuclear model is because in the center here, we have a nucleus. And you'll notice that the nucleus is made up of two different particles, and we call these subatomic particles. And these subatomic particles are the protons and also the neutrons. And we'll get into which one is which in just a second, because you'll also notice that there is another subatomic particle just outside the nucleus. And this subatomic particle exists on something we call an energy level, or sometimes referred to as a shell. And this subatomic particle that you find on energy levels or shells is called an electron. So you should notice that every atom is made up of three subatomic particles. We have the proton, we have the neutron, and we also have the electron. Now, these are just some typical 1-mark questions, but you have to remember these, and that is that, the atom is extremely small. In fact, it's so small that the atom has a radius of 1 × 10⁻⁻10 meters. So that's a 1 with 10 noughts before it. Extremely small. And just for like kind of reference, I suppose, the radius of your hair is typically 1 × 10⁻⁴ meters. So that's 1 with 4 zeros before it. So that's just to give you a bit of a scale as to how small the atomic radius actually is. And even smaller is the radius of the nucleus. And the radius of the nucleus is 1 × 10⁻14 meters. So we're getting to these really, really small numbers. Now, when we look at these subatomic particles, you could be asked to describe each subatomic particle in terms of its relative mass and charge. So what we're going to do is we're going to break down each subatomic particle in terms of its relative mass and its charge. So we've got protons, neutrons, and electrons. Okay? Protons have a relative mass of 1. They do not have any mass units. Remember that this is just relative to each other. So a proton has a relative mass of 1. Neutrons also have a relative mass of 1. And electrons, their mass is so small that we just consider it to be 0. Now, from this part of the table that we've just filled in, it should be quite apparent to you guys that, now I'll just change the color here. It should be quite apparent that the mass of an atom mainly comes from just 2 particles, and that is the proton and the neutron. And we find those in the nucleus. So in science, we refer to that the mass of an atom typically is found in its nucleus. This is where the mass of an atom comes from. Now, to look at the charge, it's not enough just to say that protons are positive. We have to be a little bit more specific than that and say that protons have a charge of +1. And we also say that neutrons have a charge of 0. Hence their name, neutron. It sounds like neutral. They have no charge. Whereas electrons have a charge of -1. They're negatively charged. So we're going to build on this. We're going to build on this idea of the atomic structure. And we're going to use this to actually break down the language of the periodic table. So the periodic table contains elements, and every single element has its own symbol. For example, O is the symbol for oxygen. Chemists are quite lazy people, and they prefer to use symbols than write out the name in full. For example, Na is the symbol for sodium. And Mg is the symbol for magnesium. Now, the key thing about these elements is each atom within the element has 2 numbers attached to it. It has a number at the top, and it also has a number at the bottom. Again, we have a number at the bottom, and we have a number at the top. And we have a number at the bottom, and again, we have a number at the top. Now, you need to know what these numbers represent. So this number right here at the top, this is called the mass number. And the mass number is made up of protons and neutrons. And the number at the bottom, this number here, this is referred to as the atomic number. Now, the atomic number, sorry, having a bit of a problem with the pen here. The atomic number is also known as the proton number.
Mike, do you know why the problem with the pen happened?
Go on.
Because last time you told us you were doing it with your mouse and we were all jealous. So
That is true.
Back at you, Mike.
That is very true. I did tell people I did it with my mouth, so I guess this is karma. But the bottom number, the atomic number, is also known as the proton number. Now, what you could be asked to do in your exams is, if you're given this information, you should be able to work out the numbers of protons, the numbers of neutrons, and the numbers of electrons. So let's just go through this with oxygen. I'm just going to put a P to represent proton. I'll put an N to represent neutron, and I'll put an E that represents electrons. So the proton number is the easiest one, I think, to solve, because remember, the bottom number is the atomic number, and the atomic number is just another word for proton number. So for oxygen, the number of protons is 8. Okay? Now, a general rule to remember for atoms, is whenever we talk about atoms, the number of protons is equal to the number of electrons. It's exactly the same. So if the proton number for oxygen is 8, then the electron number must also be 8. Now, the difficulty comes with the neutron number, because if you look at the definition for mass number is number of protons and neutrons, and the atomic number is just the number of protons. Well, to work out the number of neutrons, you would need to do the mass number, the mass take away atomic number. So in other words, this becomes 16 take away 8, because 16 is the mass number and 8 is the atomic number. So the number of neutrons is equal to 8. So we've got 8 protons, 8 neutrons, and 8 electrons. Let's see if we can apply the same rule now to some of our other atoms. So for example, we've got sodium. Again, I'll just put P for proton, N for neutron, and E for electron. Remember that the bottom number is the number of protons. So sodium has 11 protons. And because it's got 11 protons, it's also got 11 electrons. Now remember, to work out the number of neutrons, you need to do the mass, which is 23, away the atomic number, which is 11. So 23 take away 11 gives you 12 neutrons. And then for our final one, for magnesium, we've got protons, neutrons, and electrons. And I'll just pause for 15 seconds and see if you guys can work out what's the number of protons, neutrons, and electrons using the rules above for magnesium. So I'll just pause just for 12 to 15 seconds, give you guys a chance to see if you can work out the subatomic particles for magnesium.
I'll leave this one with you, Nish.
I'm actually trying.
Okay, so if we come back to our example, I'll change the color again. If we come back to our example here, remember, proton number is the atomic number, and the atomic number is at the bottom. So the numbers of protons, 12. Okay. For the number of neutrons, again, you need to do the mass number, take away the atomic number. So 24 take away 12. Yeah, something's wrong with this pen. Equals 12. Okay, so magnesium has 12 neutrons. Now, if you remember, because the number of protons are 12, that means that the number of electrons should be exactly the same. So they should also be 12. And that is how we work out the subatomic particles for different atoms. Now, the task I've set for you guys to do today involves something called an isotope. And I'm going to give you an example of an isotope. So and what I'd ask you guys to do at home, again, see if you can work out the proton, neutron, and electron number of these isotopes, and see if that can help you come up with a definition of what an isotope actually is. So carbon 12 over here, if we do proton, neutron, and electron numbers, you'll notice that all of these carbons have 6 protons because the atomic number is 6. So 6, 6, and 6. The neutron number, remember, is the mass take away atomic. So it's 6 again for this one. We would get 7 for this one, 13 take away 6. And then for our last one, 14 take away 6 would be 8. And then for our final subatomic particle, the electron, remember that the electrons are the same as protons. So 6 and 6 and 6 again. Now, what you should notice, and this would be my final point, what you should notice, for each isotope, they all have the exact same number of protons. So every single isotope has the same number of protons. But can you spot what's different? Well, hopefully you can all see that the numbers of neutrons for each isotope is slightly different. And that's what leads us to our definition of an isotope. So isotopes have the same number of protons, but they have different numbers of neutrons. And I hope that's helped someone out there today.
100%, Mike. You can see currently there's 60 people have clicked in on your lessons and watched different things. So yeah, there's definitely more than someone, buddy.
Good. Excellent.
And someone's even gone to the trouble to reshare on Facebook your lesson on Facebook. So someone's a fan. Someone wants to share you far and wide, Mike.
I do autographs as well, so
well, not with that pen. Not with that pen. You won't, Michael. Thank you so much, buddy. It's,
not a problem.
Brilliant. And you're back with us again for your last lesson of the week tomorrow, aren't you?
I will be, yes, no problem.
Thank you so much, buddy. Look after yourself.
All right, take care, guys. Take care. Bye.
See, it's so calming, Nish. So calming.
I know, I love it.
Yeah, just like you're trying to concentrate, and I just feel really relaxed, and then you're trying to concentrate. It was interesting what he said at the beginning, though, about the students and the way the students are. He finds, tutoring them online remotely, they're not as afraid to make mistakes and stuff.
Yeah, which is great.
That's because no classroom environment, no human right next to them. Do you know what I
Yeah.
mean? It just feels they're doing it in their own space, own time.
Exactly.
There's like one step towards, well, in that instance, it's one step towards a more personalised education.
100%.
All right, brilliant. Is you ready to lead us out with this one? And then, we've got a fourth lesson today. We've got Alex joining us for Spanish.
Which would be great. I'm so excited.
Oh, is that one of the subjects you know?
Well, no, I've just always wanted to learn Spanish, so
okay.
I'm gonna just jump right into the deep end. This is what's happening.
Fair play. It's all with you.
All right, cool. This is the optional task of science. Parents and students get involved. And the question is, why do isotopes have similar chemical reactions? Hopefully lots of you can answer that and get it wrong.
Oh, yeah. Brilliant. And any of the lessons that you want to catch up with are down here, Nish. What is this?
So it's called streamschool.guide.xyz, and it's a way to catch up with all the lessons. All the lessons are on there, and all the resources are on there as well. The links to all the lessons are on there. So it's really easy. You can just sign up, and there's a code at the bottom which is free. It's free to sign up. Go do it.
Can you tab to it? It's just in case you missed any of the lessons, guys. And you want to catch up, and it's just clearer. One of the things that we have here is just, again, completely free. Otherwise that would be a complete lie if we called it free. So if you just click on subjects, please, Nish.
Yeah, subjects at the top.
And then if you go to join today, any one of those, then that's where you put the code in. That is just me 123. And if you just go to subjects in the top left, Nish.
Yeah.
And there's any of the lessons we have. So just go to drama, for example.
Yeah.
And then we add them up there within by the end of the day each day. So anything that you missed before, they're just going to go and they're going to add their up in sequence. So you can follow through. If teacher says, last week we did this, or next week we're going to do that, you'll be able to go through and click on those things. And thank you so much, Nish. I'll see you again in 15 minutes.
Yeah.